Today is an exciting day because tomorrow NASA will attempt to launch its long-awaited James Webb Space Telescope. This telescope has been in development for over 20 years, literally taking hundreds of thousands of people from around the world over 2 decades to build this one incredible machine. And it's the successor to the legendary Hubble Space Telescope. But JWST is so much more than just another telescope. It will finally allow us to see the first galaxies that formed after the Big Bang. It will measure how stars form and evolve and search for signs of life elsewhere in the universe. It's just quite possibly going to be the most important space science mission in the next decade or even longer. And right now, all eyes are on the weather at the launch site. We're hoping for clear skies so we can get this show on the road. A big part of the reason why the launch has been delayed so many times is that it's not just a telescope. It's a very complicated telescope. Even before JWST left the factory, engineers had to fold it up like origami to fit it into the rocket. Then the entire thing has to unfold again perfectly in space for everything to work correctly. There are tens of thousands of moving parts, and if any of them fail, the mission could be compromised. The sheer complexity of the machine means that there are bound to be hiccups during the launch and deployment process. But the team has gone through every scenario, no matter how unlikely, and made plans to deal with them. So fingers crossed, nothing goes wrong. It's not hard to understand why. The anticipation is high. At a briefing last week, John Mather, the mission's senior project scientist at NASA's Goddard Space Flight Center, admitted to feeling relieved that the launch is finally happening. He said he's felt that way for several days. And it's not because he's tired of talking about the telescope. He says he just relieved that his team's work is finally going to be put to the test. More than 300 institutions and companies from around the world have contributed to JWST, involving thousands of scientists and engineers, both past and present. The international collaboration includes partners like the European Space Agency, the Canadian Space Agency, and academic and industry partners. Altogether, they've spent more than $10 billion on the project, including construction costs. When asked what he's most excited to see, Mather replied, "All of it." He said at a media briefing, "I think what we're going to learn. This is really the power of doing this great, big, ambitious project. We're going to learn things we don't even know what's out there yet." JWST was designed to tackle some of the biggest and deepest questions in astronomy. What did the universe look like just 100 million years after the Big Bang? How do stars and planetary systems form? Are there planets similar to Earth elsewhere in the galaxy, and could they harbor life? To answer these questions, JWST needs to collect infrared light from objects so distant that their visible light has been stretched beyond our ability to detect it. Luckily, this isn't as far-fetched as it sounds. As the universe expands, light waves leaving distant galaxies are stretched, shifting them toward longer infrared wavelengths. This phenomenon, known as the Doppler effect, also makes the light waves of distant galaxies appear redder. Hence the term redshift. The farther away a galaxy is, the faster it is receding from us and the greater its redshift. By observing the redshift of distant galaxies, astronomers can determine how fast the universe is expanding, and whether it will continue to expand forever or eventually collapse in a heat death, known as the heat death of the universe. We won't know how fast the universe is expanding without JWST, and thanks to its advanced technology, JWST will be able to measure redshifts more accurately than ever before. And JWST doesn't just measure light, it takes pictures too. Astronomers use these images to compare the light coming from different parts of an object, which helps them analyze the object's chemical composition. They'll also help track the speed of galactic evolution. By comparing images of nearby galaxies to those of ancient ones, we can better understand how structures like the Milky Way evolved over time. One of the main reasons astronomers are so excited about JWST is that it will peer back 13.5 billion years to observe the first galaxies. It'll do this by looking at the light from the earliest galaxies that's been shifted into the infrared. These galaxies are incredibly faint, though so faint that it's doubtful that even Hubble would be able to see them. That's why we need JWST. Another reason JWST will be so good at spotting distant galaxies is that it will be located at a point of gravitational equilibrium, called Lagrange point 2 or L2. L2 is about 4 times farther away from Earth than the Moon is from Earth. From this position, the Sun, Earth and Moon will always be on one side of the telescope, making it possible for a single sunshield to protect JWST from the glare of these bright celestial bodies. The location is ideal for a space telescope because it stays in a fixed position relative to the Earth and Sun. Also, L2 is a spot of stable gravity where a spacecraft can orbit the Sun in synchronicity with the Earth. So JWST will save lots of fuel by not having to fight against the Sun's gravity. With this strategic placement, JWST will be able to focus on deep space without interference, making it easier to detect the faint light from early galaxies. To reach L2, JWST will travel about 1.5 million kilometers from Earth. The trip will take about 48 days and the telescope must be kept extremely cold to operate properly. The only way to achieve this is to shield it from the sun's heat. So that's why JWST's sunshield is so big. It's 22 meters by 10 meters, about the size of a tennis court. It's coated with aluminum to reflect sunlight and keep the telescope cool enough to detect faint infrared signals. Beneath the sunshield are 4 science instruments that can detect light from the infrared range of 0.6 to 28.5 microns. One instrument is a near-infrared camera that will detect light from the earliest galaxies. Another is a near-infrared spectrometer that can measure the chemical properties of galaxies. The third instrument is a mid-infrared instrument that can detect light from cooler objects like brown dwarfs and comets. The fourth instrument is a fine guidance sensor that will help guide the telescope and fine-tune its focus. The observatory should last at least 5 years, but the team hopes it will last 10 or longer. And when it does, it will return unprecedented views of the cosmos. You can bet we'll be here to show them to you. A successful launch tomorrow would be a cause for celebration. It would mean the end of years of hard work and preparation. It would mean that a new era of space exploration is beginning. It would be a time for all of us who love space and science to come together and celebrate the incredible achievements of humanity. What are your thoughts on the upcoming launch? Are you excited to see what JWST will find? Let us know in the comments below. And thank you for watching.